Hello viewers, welcome back to the channel. I hope you are doing good. Today we are going to take another question from Blind 75 series. This is LeetCode 347 top k frequent element. So let me read out the question. Given an integer array nums and an integer k, return the k most frequent elements. So basically we have been given an array whose name is nums, and this array will be containing the integer values, and we have been given another integer, that is k, and we have to find the k most frequent element. So first let's try to understand what is a frequent element. So basically, if in an array something is getting repeated, so that means that it is kind of frequent in the array, right? So most frequent is something which is getting repeated most number of times. So let's suppose, like here in the example we have been given, 1 is occurring thrice, right? No other number is occurring that number of times. So 1 is most frequent element. If I ask you, okay, this is the first frequent element, give me the second frequent element, then it would be 2 because 2 is coming twice. So similarly, a person can come and ask us, okay, give me the third most frequent element. And likewise, it will keep on, right? So now we have generalized that thing into k, where will be given k2. So that means we have to give the first two frequent element. If k is 3, first 3, k is 4, then first 4. And there might be a case where the number of element we have in an array, let's say that is n, and k is also n. In that case, literally we have to return everything. That's an edge case. If k is equal to n, then we have to return everything out of this. And even if k is more, in that case also we have to return everything. So we don't have to do anything. We can just say, okay, you want n frequent, like I have n element and you are asking me n frequent element. So literally everything is frequent in it, because everything can occur at least once. So let's try to understand it from an example. So let's say I've been given an array which is having such this value. So for solving this, anyhow we need to find the frequencies of each numbers. So we'll have to create a frequency map, and after creating the frequency map, we will keep the values for all the numbers like we have done it here. And after doing this, we need to get the top values, right? So we need to basically sort it. So I've written down the approach. This is the brute force approach. Like normally the most intuitive way to solve the problem would be first sort the map. Like we have created the map. So map is like very basic thing. We have to create a frequency map. Until unless we don't get the frequencies of each element, will not be able to solve it. So this is the first part of it. After creating the frequency map, the brute force solution will say that, okay, sort the map based on the frequency. Based on the frequency, you can sort the map. After sorting this up, I can just go and take the first k value, right? I can go and take the first k element and return the element in the result array. And finally, we need to return an array called the result or answer or something which is part of the answer. So that will not be counted as a space, right? Because answer itself is asking to return a array. So that is not part of space complexity. So now what will be the complexity of it? So for creating this map, we need O of n time, and we will be needing n log time to sort the map. So out of this on and n log n is the higher value between these. So overall time complexity would be n log n. So what we can do better? So this is the brute force approach. So we can do better. We can use heap. I've already explained about heap, what is max heap, what is min heap, and how we can create our own heap, like the own implementation, because JavaScript doesn't have the internal implementation of heap which we can use. So we have to create our own heap. I have a separate video on that, and I will give the link of that video in the description. Please go ahead and watch that before trying to understand the heap solution what I'm going to discuss. So pause here and go there and please try to understand, then come back and let's understand this. So now if you would have gone through my heap video, so you already know what is heap. So heap can be max heap and min heap. So here solving the question, we can either use the max heap and either use the min heap. So let's say first, let's take the example of max heap. If we are going to use the max heap basically gives the highest value or the greatest value among the heap that will be on the top of it. So heap basically gives the value in O of one time, the top value. So top value of heap we can get in O of one time. If it is a max heap, top value will be the greatest value or the largest value among the heap numbers. And if it is a min heap, then the top value will give us the smallest values among the numbers. Cool. So now max heap, what we are going to do? First, we need to create the heap having all the numbers. That is going to take us the O of n time building the heap. We'll be building the heap using frequency map. So frequency map will have all the keys, I mean all those numbers, and we are going to have those many values in the heap. That is going to take us O of n time. After creating that, will have to take out k element. So let's say I have created the heap, which is the max heap. I have all the numbers, n numbers in it. Now I need to take the greatest. So max heap can give me the greatest value among it, right? So in the heap, first of all, in the heap, how we are going to store the value? So heap takes a comparator function. In comparator function, will mention that okay, you keep the values according to their frequencies. So the value which is having the most frequency will be on the top. So if I'm taking out the value from the heap, from the max heap, it will give me the value which is having the most frequency. So I'll keep on plucking out the values, taking out the values one by one, and I'll keep on repeating this for the k time. So because I need to get the k numbers, right? So now we'll have to understand the complexity involved here. For taking out k element from the heap, whenever we take out the element from a heap balances the values among itself, so that on the top again it has to put the number which is having the highest value. In our case, we want something of highest frequency, so it will balance itself and keep the highest frequency value at the top of the heap. So now that operation takes, the balancing act takes heap to log n time. So if the length of heap is n, so it will take heap to log n time to balance itself, right? Now we will be plucking values k times. So heap has to balance itself k times. So that's why the total time complexity would be k log n. Okay. And at the last, after taking out those case value, we can just return it in the result array and done. So that is the heap max heap approach. Now there is another interesting approach. If we'll think a little differently, we can take the leverage of the min heap as well. So in the min heap approach, the top value will be the minimum value, the number which is having the minimum frequency that will be on the top of the heap. So using the min heap, we won't be creating the min heap using all the numbers. Unlike the max heap, we have taken all the numbers and created a heap out of it. That took us O of n time. But here we are not going to do that. Here we have a different approach. We know min heap can give me the smallest value, right? So I'll take benefit out of it. I will maintain a fixed length of k. The heap length will be k, that is fixed. Now I'll be taking one value out of it. Like let's say I have a fixed width of k. Now I'm putting one value into it. So my length, whatever I have fixed, I'm violating because now it has k plus one numbers. So to accommodate a new number, I'm going to remove the one which is the lowest. Okay. So because I know the heap can give me the minimum value out of it, right? So if I'm putting something new, I have to remove the minimum out of the heap, then only I can keep the new, right? So that's how what happens. I will be taking each value from the frequency map one by one and will keep on putting in the min heap. And once I reach k plus 1, I'll remove the smallest possible number from that. And since it's a min heap, it can easily give me, it can easily remove the minimum number out of it. So that's the essence of using the min heap. Here we just have to maintain the k length mini, and we can just remove the the minimum number in log n time. So again, when we are removing the number, like we are dequeuing the number, it will take us the log n time. But here the length of heap is k, so it will take us the log k time. Log k time will be needed to remove each of the element whenever we are plucking something out of it. How many times we will be doing this operation? We'll be doing this n number of time, because anyhow we are going to put n numbers in the heap, right? So we'll be repeating this operation n times. So that's why the time complexity would be n log k, because we know for taking each, like reading each number, we need n time, right? N time. And for every number we have to do this balancing act of log k. Why log k? Because here the heap size is k only. So this is, so the overall time complexity would be the n log k. So compared to a sorting approach, both of these time complexity k log n and n log k is less than n log n, because k is always lesser than the n log n, right? N log n will always be greater than k log n or n log k. So anyhow, both of these approaches will be better than the sorting approach what we have done, right? So using heap has improved the time performance. Now we'll understand which is better, either to use max heap or min heap. So basically max heap takes k log n time and min heap takes n log k times, right? Now what what are the values, different values k and n take? So generally k will be smaller. K will be smaller than at max. K can go till n, right? So let's say I'm taking a smaller value of k. Generally the value of k will be smaller. So I'm taking k as 8 and n as 1024, that we can express as 2 raised to the power 10, and 8 we can express as 2 raised to the power 3. So if I calculate k log n, that is for the max heap, it comes out to be 80, because if I substitute 1024 value, that is 2 raised to the power 10, and since it's a base log 2, so this will be 1 and 10 will come in the front, right? This is the simple mathematics. Similarly, here the value comes like 3 around 3000, and here it is coming like 80. So we can see that k log n is better than n log k. So basically max heap time complexity is better than the min heap time complexity for the smaller values of k. But if k is equal to n or k is even higher than n, in those cases min heap will be better, because it will reverse, the value will reverse in that case. But in our case k won't be greater than n, because we already have discussed the edge case. If k is equal to n or k is greater than n, then we are just going to return all of the numbers, we don't have to take care of that. So I think in our case, if we are going to use heap, max heap will be the better option, but it doesn't matter so much. More or less, it takes almost same time, but somewhat for smaller values, max heap approach is better than the min heap approach. Now let's discuss the optimal approach for solving this. So approach might look little new to you, so you might need a little bit of time and you'll have to wrap your head around it to understand it, but the code will be very easy, trust me. In the nums array, a number can appear at most n number of times. If n is the length of the number array, sorry, n is the length of the number array, then a number can appear that number of times, right? The length of the array. And what is the minimum number of time a number can appear? Minimum is 1. So a number can appear at least once, or a number can appear at most length of the array, that is n. Otherwise, the frequencies of number will lie between 1 and length of the number, right? So we can take benefit out of it. Now, what we can do is, we know that a number in a nums array can have frequencies of 1 or at most n. So why not we create buckets which can hold values of different frequencies, right? A bucket named 1 can hold all the numbers which is having the frequency of 1. A bucket named 2 can hold all the numbers which are having frequency of 2, and a bucket having name as n can hold all the numbers having frequency as n. So we can take benefit of this bucket, right? All these buckets will be holding the numbers having these number of frequencies. And this approach is called as bucket sort as well. This is a concept which will be helpful in other questions as well. Please try to try to understand this. So now we have basically created the fixed sizes of different buckets, and all these buckets are basically arrays which will be holding the numbers. Now if let's say I need the values which is having the most frequency, so I can start reading values from the backward to front. I'll go from back to the front and read all those numbers having the, because most frequent, I need most frequency first, right? So if I read from back to the front, then I'll be getting that most frequency first, then lesser frequencies one by one. And once I get the k numbers, I can stop getting values from the bucket. So this is what how the our approach will look like. So now the time complexity again, we need to build the frequency map. So that will need us O of n time, and for creating the buckets again, we will need O of n even lesser than that, because the bucket will be created only for specific numbers. And for taking k numbers from the bucket, we have to read k times, right? Basically k times, yeah, but more or less this is again till O of n. So overall this is like 3n, which we can write it as O of n. So big O time notation will give us O of n time complexity of it. And if I talk about the space, so we are taking a bucket here, right, of all the fixed sizes. So basically O of n for the space complexity as well, if I talk about, that will be O of n because we are taking n length bucket. Okay, so let's solve the problem. First, we'll solve the using the heap approach, and then we'll extend it to the counting sort. So first we are going to solve it with the heap approach, but for heap we need the heap class which we have created in my heap video. So I'm just going to copy all that code, and whenever we have to use heap, I'm going to copy the same code because there is no heap implementation in our JavaScript. So this will be the way to go. So first I'm going to handle the edge case where if num dot length, that is n, if that is less than or is equal to k value, that means k is like greater than the num's length or even equal to that. In that case, every number is the frequent number, so we can directly return the nums. But if that's not the case, so first we'll take the frequency map. So new map, and we'll read numbers one by one. So const num of nums, and we will try to set the values. So I will just try to set the values in frequency map. So how we store values in map? Key comma value. So value, I'll have to take the previous value and add 1 to it. So how we can take the previous value? I can do frequency map dot get num, but the thing is we might not have the previous value because I am getting this num first time. In that case, this will be undefined. So I will have 0 for as a default case. Now I got the frequencies of it. Everything now will be creating a heap. So first I am going to create a min heap. So by default heap would be min heap. And after getting the frequencies, what we are going to do. And now we are going to read the values from the map. So value from map comes as an array as key value pair, key value from frequency map. Sorry, we have to use of, and this key will be number, so I'll call it as num, and value will be frequency. So this is the way to read values from map, where we can use for op and give the map here, and here we can get the key value pairs. So now I'm getting the number and frequency, so I need to keep it in the heap. So I will use the enqueue function and keep the values. So I'm going to keep values in an array. I can keep the value as a object as well. So basically, if I'll keep the value as an object, so heap will be having array of object. If I'm going to keep it as an array, so heap is going to have the values as an array of array like this. It will have multiple values, and the first value will be num, and the second value is going to be frequency. Okay, so now I'm going to put it like the array, and here I am giving the frequency. The second value is the frequency. Now since it's a min heap and these are not just the array of numbers, it's an array of array, so that's why I have to give the comparator function so that it understand how to do the comparisons. So since we need to compare based on the second value in the array, so what I'm going to take, I'm going to take the b value, the second value. So it will be a minus b, because we want it to be an ascending order. This is a min heap, so value goes from smaller to greater, right? That's why a minus b. And now we have stored the value. So now what we have to do, we need to check what is my size. So I'll just check after inserting this value, what is my size. So if heap dot size is greater than k, that means we'll have to remove the value from heap. So we'll have to do heap dot dequeue. As I discussed before, in that case, what we are doing is we are basically removing the extra minimum value, because we have to maintain the fixed size min heap, and the size would be k. Since we are going beyond k, I am removing the value, and the removed value will be the minimum value, I mean the less frequent number. And now after doing all this operation, I will have a fixed array. Sorry, I will have a fixed size heap. So I will take the size here. If the heap size is greater than 0, till then I will be keep getting the values in my result array. So I'll take a result array, and in the result array I'm going to put the value. So result dot push, and I'll have to dequeue the values, and the value will come as an array, right? So the first value will be the num and the second value would be the frequency, but I need the first value. So I will do, because since it's an array, so I want to take the 0th index value out of it. That's why I've given 0 here. And now at the end, I can just go and return the result, and let's run it and see if it works. So this is working fine. I will submit it and this works fine too, but you can see the time complexity is not that great. But now we'll try to change it to the max heap solution. So max heap, we need to convert it to max heap. In that case, this will be B and this will be A, because we need to have values in descending order. And now in max heap case, the first thing we do is we create the heap of size n, I mean giving all the numbers. So what we are going now, we are going to call the heap build function. So heap dot build heap, which is going to take the array. So we need to create array from the frequency map, right? So what we can do is we can use array dot from, and it will take the frequency map, and then we will have to uh, yeah, I think we can do map, because we can get values one by one, and map will be giving us values similarly like num and frequency. We can just return value like that. So here we can return an array having value num and frequency. So we are basically taking each of the values from the heap, sorry, frequency map, and then looping through it and trying to maintain an array of array, and that we are going to give directly into the heap. So now creation of heap is done. Now we need to take out the values from the heap. So for that, what we'll have to do is we'll have to create this while loop as until we reach heap dot size. So basically we can based on k, like if k is greater than 0, we will keep on plucking the values from the heap. So we'll be putting the values, and we'll have to remove this. Yeah, so now we need to take k values, right? So initially k will have some value, let's say 2 3 or something in that. Now what I'm doing, I'm taking values, and after taking the values, I'm decreasing the k. So when once we our k becomes 0, we'll have all the values in our heap, sorry, in our result array, and now we can return the values. So this also works, and let's submit it and see. So this is also pretty much giving the same runtime. So not much of a difference among these two. So this was the heap approach. Now we are going to solve it using the sort approach. So in that case, we don't need heap. So I'm removing that. We'll be needing result. Okay, fine. Will be needing this. That is also fine. And we'll have to create a count bucket, or we can call it as bucket will have all the count. So we need to create an array of size length plus 1, because a number can occur at most as n number of times. Since we start from 0, so we'll have to have values, and we want to have values till n, right? So we want to have bucket for number n, and since in array we start from 0, so at most, if I'll not give length plus 1, I can have bucket at most n minus 1, right? So that's why I'll have to give n length plus 1, so that I can have bucket of number n. And now we can fill it with null, and then map through all this array, and now we can return an array. So basically what I'm doing, I'm creating an array of buckets like this all these internal arrays are the buckets which will be holding numbers, and this is having the size as n plus 1. Okay, cool. So now what is going to be the next thing? So now we'll be having a for loop, so that we can read values from the end. So we will start reading values from the end, right? So the last value we'll have to read, that will be bucket dot length minus 1, and will be doing all this till the time we have enough number in our result. I mean result dot length is less than k. Once our result have k values, we don't have to take values from the bucket, right? And we'll keep doing I minus minus. So we are reading values from the backward direction, because we know the last bucket is having all those numbers which is having frequency as n, right? So first I am going to take that most frequent value. So that's why I'm reading from the backward. Now, what is the next thing? We need to get the values out of it. So for taking values out of the bucket, we know that each of the bucket is again an array. So we need to go through the array and take the values out of it. So num of the bucket of I. So whatever is having in bucket of I, I'm going to read each of those and I'm going to put it in the result one by one. So all the values are going into result, and we might reach a situation where my result dot length is almost equal to k. In that case, I can just return my result, because I don't want to go further and collect more values. I have enough values, I can just return my result, and I don't think we require this anymore, and this should work fine. We have everything. Let's run it and see. And this is giving me an error, buckets of I. So somehow something is getting missed here. So my bad, we have not filled the bucket. So for first we need to fill the bucket, and for filling the bucket we will have to loop through our frequency map. So frequency map is going to give us values in key value again. So num and the value would be frequency of frequency map, and here I'm going to fill the value in the bucket. So every bucket is having a frequency assigned to it, right? So the bucket of this frequency can hold, because that's an array. So I can push this num there. So what basically is happening? Let's say I got as frequency as n. So I went here and put this number in this array. Okay, now run it and see if it works. And this works fine. And the time complexity you can see is very good now, because the time complexity now is O of n. This operation takes O of n time. This operation again takes O of n time. This operation takes O of n time. And this again takes O of n time. So overall, this is O of n operation. I hope you understood all of the solutions well. Please like my video and please subscribe to my channel as well. You guys are not subscribing to the channel. Please subscribe the channel. It will help me immensely. Thank you and keep watching for the next videos. See you in the next video. Bye.